I'm Anil Kumar, and in this series, we are going to discuss how to write quadratic equations when the roots are given to us. To begin with, let's look into this question carefully. It says how to write quadratic equations for the given roots, and we look for a general solution. The general solution will be for the roots at x equals to m over n and x equals to p over q. So that is a very general form. M, n, p and q can be any integers, right? So they can be any integers, okay. Now, so we are working in the domain of m, n, p, q belongs to integers, which could be written as I or sometimes c, right? Both, okay. Now, what does it really mean? Now, when I say that we have a root at x equals to m over n, it really means what? Let me show you by rearranging this particular equation. We can multiply, we can get n times x equals to m, and we get n times x minus m equal to 0. That is what we mean. Root at x equals to m over n really means that n times x minus m is equals to 0. Similarly, what do you understand by saying that root at x equals to p over q? Well, rearrange that also. So what you get here is q times x equals to p, or q times x minus p equals to 0. Now when we get these two roots, it's simple to write a quadratic equation. They become two factors, right? So these two are your factors. These are your factors, which when multiplied, these are linear factors, which when multiplied will give you quadratic equation, right? So what you really get here is a quadratic equation, nx minus m times qx minus p equal to 0. And that is the required quadratic equation, right? Do you understand? That is the required quadratic equation. Of course, this is in factored form. You can expand and write it in standard form also, or any other form you can convert this into, right? Important thing here is that if the roots are at m over n and p over q, then that is the kind of factors you get. Let me take a few examples to help you out. So we'll kind of take different kinds of roots, right? So let's take one example where the roots are x1 is, let's say, 3 and x2 is, let's say, minus 4. In that case, if these are the roots, right, then what can be the quadratic equation? The quadratic equation will be, bring 3 to this side, so it is x1 minus 3 equals to 0, and here will be x2 plus 4 equals to 0, right? So, I mean, equal to 0. So the factors are x, you can replace x1, x with x, right? Roots means x is equals to 3, correct? So x minus 3 times x plus 4 equal to 0. Do you get the idea, right? So that is how you get the equation, right? Let me take another example with fractions. So if the roots are at x equals to, let's say, 2 over 3 and at x equals to minus 1 over 2, in that case, we could write down the factors like, let's look into this one, 3 times x minus 2. Do you see that? 3 times x minus 2. So the first factor is 3 times x minus 2. The other one is 2 times x, right? 2 times x. And when you bring this 1 here, it becomes plus 1 equal to 0. You get an idea, right? So that is how you can quickly get the equation, right? Now here is your practice question, right? So practice question for you is that roots are at minus 2 over 3 and 5. Well, that's question number 1. And question number 2 is roots at 1 and 2 over 5. Okay. So those are the roots. What kind of equation do you expect? We're looking for quadratic equation with the given roots. Here is the answer. The first one, 3 times x, and when you break minus this side, it becomes plus 2 times x minus 5. Do you see that? And equals to 0, and here will be x minus 1. That ensures that if x is 1, this factor will be 0, times 5x minus 2 equal to 0. If I substitute x as 2 over 5, I'll get a 0 here. So that becomes a factor. I hope you got the idea, right? So in this video, we have covered how to find quadratic equations when we have roots which are rational. We'll look into examples where the roots could be imaginary also. So I'll give you a link for those. So we'll have slightly different strategy there. However, this kind of strategy works at that place also. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos, and feel free to write down your comments. Thank you for watching.